Messages took up to 3 seconds to appear. A new microfrontend loaded from a different subdomain, which wasn't in the server's allowed origins. The WebSocket handshake failed silently, and the client fell back to long polling without any error log. Here's exactly why. First, let's understand what WebSockets are and why they're essential for real-time apps. Welcome to TheCodeForge. Before we dig into that production issue, let's cover WebSockets explained. WebSockets start as an HTTP request that upgrades to a persistent TCP connection. Once established, both sides can send data anytime, reducing overhead compared to polling. The handshake is an HTTP upgrade request. The server must return 101 to establish the WebSocket. CORS is enforced on this upgrade response, not on individual messages. The browser sends an origin header. The server must include access control allow origin in the 101 response. If missing, the browser blocks the connection silently. When CORS fails, the browser fires owner and enclose with code 1006, but no descriptive error. Client libraries like Socket.io fall back to HTTP polling, masking the issue. Here's a Node.js middleware using the WS library. It checks the origin header against an allowed list, logs rejected origins, and explicitly rejects with 403. A handshake timeout is essential. If the server doesn't respond with 101 within a few seconds, close and retry. Log the response headers to diagnose proxy issues. This Python snippet uses a Syncio timeout to catch a stalled handshake. It also catches invalid handshake and prints the HTTP status and headers for debugging. Heartbeat pings detect dead connections. Without them, zombie sockets accumulate, wasting resources. Implement ping-pong at the application layer. This server-side heartbeat sends a ping every 30 seconds and waits 10 seconds for a pong. If timeout, it closes the connection, preventing zombie sockets. This is the same issue we highlighted at the start. Here's exactly why that happened. A new microfrontend loaded from a different subdomain. The WebSocket client used that subdomain, which wasn't in the server's allowed origins. The handshake failed silently, and the client fell back to long polling. The fix was to add the new subdomain to the server's allowed origins list. Also added logging to capture rejected origins so future incidents are visible immediately. WebSocket CORS is separate from HTTP CORS. Setting HTTP CORS headers does not affect the upgrade handshake. You must handle CORS explicitly in the upgrade handler. Client-side fallback masks the failure. In development, force WebSocket-only mode to surface CORS issues immediately. Monitor WebSocket success rate in production. Without logging the origin, you have no idea which origin was rejected. Always log the origin in your upgrade handler, even for successful connections. Add explicit logging of the origin header in your WebSocket upgrade handler to catch silent CORS rejections. This snippet logs the origin for every upgrade attempt, making it easy to spot misconfigurations in production logs. Reverse proxies like Nginx and Amazon Web Services strip the upgrade header by default unless explicitly configured for WebSocket passthrough. Always verify your proxy config, e.g., proxy set header upgrade HTTP upgrade, before blaming the client library for handshake failures. Implement a handshake timeout on the client to detect silent failures. If the onOpen event doesn't fire within a few seconds, assume the handshake failed and retry with exponential backoff. This snippet shows a timeout wrapper for the browser WebSocket API. Use curl to simulate the WebSocket handshake and check for access control allow origin headers. Also enable debug logging in your client library. Let's run through some common interview questions. What happens when a WebSocket handshake fails due to CORS? Browser fires owner and enclose with code 1006, no descriptive error. How is WebSocket CORS different from HTTP CORS? No preflight. CORS checked on upgrade response. Wildcard not allowed with credentials. How would you debug a WebSocket connection that works locally but fails in production? Compare origins, check proxy config, use curl, enable debug logs. And a few frequently asked questions. Why is WebSocket CORS failure silent? Browser doesn't expose error details, client falls back to polling. What headers are needed for WebSocket CORS? Server must respond with access control allow origin matching the client's origin. Can I use wildcard origin with WebSocket? Only if no credentials, otherwise specify exact origins. To recap, WebSocket CORS is checked on the upgrade handshake, not on messages. Silent failures degrade performance. Always log origins, implement heartbeats, and don't rely on client fallback. Ready to go deeper? Up next, long polling versus SSE versus WebSockets, then IP addressing and Anycast. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.